Hello class, this is Mr. Eggleston, and this is lesson 6.8 for Algebra 1, Radicals and Rational Exponents, and this is the check your understanding. I've been having issues with my iPad and my pen, so let's see if this works now. It says rewrite each expression using exponents instead of radicals. So a square root of 20 can be written as 20 to the 1/2 power. Remember, there's a little 2 as the index because it's a square root. And the nth root of x is the same thing as saying x to the 1/n power. So the cube root of x becomes x to the 1/3 power. And the square root of w to the 5th power can be thought of as w to the 1/2 raised to the 5th. You multiply exponents, so that's w to the 5/2. And there you go. That's how you can rewrite each of these with rational exponents. Remember, the word rational really implies, rational numbers are pretty much any number that can be written as a fraction. That includes integers like 5, 6, 7. 6, 7, because 6 is 6 over 1, 7 is 7 over 1. That's a ratio of integers. So they're rational. What's not a rational number are numbers like pi, which you may or may not have seen before. Pi is defined to be the ratio of the diameter of the circumference of a circle to its diameter. All right? And you probably have it memorized to 3.14, but that's an approximation because it's an irrational number. It goes on forever, never repeating itself. And when they say repeating, they're saying sequences of numbers don't repeat. Okay. So the second question is simplify each radical. So they're asking for the square root of 32. What you have to think about is 32 can be the product of two numbers. Some of you might say it's 4 and 8, which is fine. 4 is a perfect square. I always caution my students to think in terms of perfect squares. If you don't know what a perfect square number is, make a list of numbers 1 through 10, and then on the second column, square each of them. And then that second column is a list of perfect squares up through 100. All right? But 8 can be broken down as 4, which is another perfect square, times 2, which is prime. So 4 times 4 is 16. So if you thought of square root of 32 as a square root of 16 times 2, which can be the square root of 16 times the square root of 2, which equals 4 square roots of 2. Notice you don't need the dot between the 4. You could put a dot here to force people to remember that's multiply. But if you see a number written like this, that is the same thing as saying 4 times the square root of 2. Just like 4x is the same thing as saying 4 times x. We just don't write the little dot for multiplication. All right, 300. The perfect square that goes into 300 is 103 times 3. So it's the square root of 100 times 3, which is the square root of 100 times the square root of 3, which is 10 square roots of 3, or 10 times the square root of 3. 48, again, these are numbers that you might have to do a factor tree on because you may not know 48, what goes into it, but I know that 4 goes into it, and that's a perfect square. 4 goes into that, and that's goes into 4 once, twice, and that's 12. 4 times 12 is 48. 12 can be broken down as 4, which is, again, a perfect square, times 3, and 3 is prime. So 4 times 4 is 16. So the square root of 48 can be thought of as the square root of 16 times 3, which is the square root of 16 is 4. Square root of 3 is just, we leave it as the square root of 3. That's fully simplified. Notice what's underneath the radical, what's inside the radicand, if you will, is the number 3, which cannot be broken down any further. Now, which of the following expressions is not equivalent to xy to the 3/2 power? Well, the fraction, the 2 on bottom, means that's the same thing as saying the square root of xy raised to the 3rd. So do we have that showing up? Not really. Which is also the same thing as saying xy raised to the 3rd power square rooted. All right, and that is a. So a is like it. The second one, xy to the 3/2, is x to the 3/2 y to the 3/2, because we can distribute the exponent. This says x to the 3 times y to the 1/2. No, they're both supposed to be 3/2. This is wrong. This is not equivalent. And just to verify, c is just what I wrote there, so that's the same. And you could, since they're both over 2 here, you can have this as x cubed y cubed to the 1/2, which could also be the square root of x cubed y cubed. So all of these are equivalent statements, all right? Just different ways of writing the same thing. Right? Write at least 3 expressions that are equivalent to the square root of 40, or 40 to the 1/2. Well, one of them would be 4 to the 1/2 times 10 to the 1/2. That would be 2 times 10 to the 1/2, which is also 2 times the square root of 10. There's lots of ways you could write it. So there's 3 different ways of writing the same thing. All right? And there you go. Have a wonderful day.